Hey, we have another in a series of videos on the Lambert W function. If you haven't watched the introduction video, I'll provide a link in the description to that, and also we'll have a link at the end to the full playlist. So we have this problem, x cubed times e to the 5x equals 27. Again, I want to solve this using the Lambert W function. On the right side, we have a few tools that we can use. Primarily this one on top here that we say for the Lambert W function, if we have the input as x e to the x or something in that form. So we're going to want to manipulate this equation to get it into something of this form here. But it doesn't have to be exactly that, of course. It could be like, we could do like a u substitution. We could also have something like, not the u substitution we use in integration, but just a general substitution. And then this would also return this value. And then we also have this second equation down here, which is useful, particularly for how we want to show our final answer. Okay, so back to the problem. My first thought was to try to use the natural log around this, but it actually didn't work out too well for me earlier. So what I'm going to try is, the main problem in this situation is we already have our e, which looks, we're getting close, we're not too far off from this, right? We already have something and we have something around an e, but we notice this and this are really different, and the real problem is the power. So what I want to do is address that power first. What we can do actually is take the third root on both sides, take a cube root on both sides, and we'll just write it as a third. So rewriting this, we'll have x cubed e5x 1 to the 1/3, and on the right side we'll have 27 to the 1/3. The cube root of 27 is just 3. Then what we'll do is we'll kind of break this apart. We'll have x cubed to the 1/3 times e to the 5x 1/3. Then distribute on each, bring this inside of the parentheses. So we're gonna have x e to the 5 times a third is 5/3, x equals 3. And now this is pretty good because, again, bring our focus. We want this to look like this right here. And we're pretty close, we just are missing this 5/3, but that's easy enough because we can multiply by 5/3 on both sides. On the right, our 3's are going to cancel and we'll just have 5. And so then let's just rewrite this whole thing real quick. And remember how I mentioned earlier, we could almost do like a u substitution. If we want, we could say u is 5/3 x, and then we have the same u around e. So this is essentially Lambert W u e to the u, which is exactly the same as what we have there with just a different variable. And then this would equal u. So then we'll come down here and we'll apply our Lambert W on both sides. And then our Lambert W on the left side, this result is just going to be 5/3 x. And then we'll just have our Lambert W of 5 here. But then we want to solve for x, so we can just multiply both sides by 3/5. And then for our answer, we're going to have, this is going to be x, because this is going to cancel here. So we're going to have x equals 3/5 Lambert W of 5. When I put this in the Wolfram alpha, this came out to approximately 0.79603 with many more decimals. And there's only going to be one real solution. This is going to be the only real solution for this. Now, how do we know that? A couple ways. So let's look at the graph first. So again, just looking for real solutions. We have this graph of, this is basically, this is my rough sketch of how the graph looks. The left side, this piece here is x cubed e to the 5x. This is just like it's 0 and then it just spikes up immediately, which you can expect because you get two exponential functions. They're just going to grow really quickly. And then this is going to be our y equals 27. And so we have this one clear intersection point. So another way to see if there's just one real solution, we can look at this. We can just look at the Lambert W function. And at the value 5, let's say 5 is right here, we can see we only have one intersection point with the Lambert W function. So it's only going to have this one real solution on our branch right here. The only time you have to worry about a second solution from the Lambert W function is just in the negative area between 0 and this right here is minus 1 over e. So if you're in this area, that's when you get a second solution, right? Because if, like, let's say you're around here at like minus 0.1, you end up with two points of intersection here. So this would represent two real solutions. But we're in this case here, so we only have one real solution. Again, I got this problem from my quiz, Lambert W challenge. We also have the quiz, Lambert W function. I'll provide a link to the introduction video and the full playlist. Thanks for watching.